for a long time. And so once it's done, it'll give you a success. It'll say, hey, this finished and whatever. And so then if it's done and this file is, the FEM file has been finished and it created some results files, you can click Hyperview and it'll open up those results files in Hyperview. Now I'm just going to do that manually. So CAD programs, HyperWorks, Hyperview. And then I'll just show how to do a few, the last part of the lab, or the tutorial, just goes through how to view your results. So I'll try and show you how to do that. Are there any questions up to this point? Great. Okay. What's up?
I have an example of the Linux versus Windows.
Oh, go ahead, yeah.
Yesterday, guys, I was working, I'm in the NX lab, and so I was working on the second half of the lab yesterday. And I created a model, put it in, started running on the Windows machine, let it run all night, and next morning, and it had only completed 7 iterations on the model. And then I came in that morning, and I took it, and I took it over to the Linux machine. In 6 minutes, it had finished solving the entire model, and it was like 24 iterations. So it would have taken 3 days on the Windows machine, but it took the Linux machine about 6 or 8 minutes to do.
It really is night and day.
Yeah, like a huge difference.
Did you just do the Linux Blade, or was it like the actual box?
No, I just did a Linux Blade.
There you go. That'll work for you. Okay, so here, so 2 things just happened. Hyperview open, but also, so this just finished. So if the process was completed successfully, it's ready to run. So I can just close this window and set on optimization. I click OptiStruct, and then I just let it go. So this, at this point, once you have that checked, then you would just go into Linux, open up your file again, and then just do this. Like everything here is going to be ready, and you just go into this window again and just say optimization. So that one will sit for a while. And then, so when you're done with the results, when it tells you, like I said, you click Hyperview, and it'll open up Hyperview for you already. In this case, I'll just load some results that I already had. All right, so the results files are H3D files. See these? So S1, so it has 3 different H3D files for each of those 3 load cases. For the brake load case, for the corner load case, and for the pothole load case. So, and when you open this up, right now there's only 1 page, but if you open up multiple ones, you can have multiple pages and you can flip through them and look at the different results. So here, if we go to linear static, and let's go to the contour button. So this is the contour button here. And this will create a contour plot of our thing here. The result type, we want displacement, and set to magnitude. And we click apply. And here is a plot of the displacement. And it gives values of how much it displaced from here. And, all right, now if we go to the deform toolbar, which is this one, toolbar button. Result type, we want displacement. Scale, we want model units. And type uniform. And then for the value, we want to put this in a value of 10. So we're going to magnify this thing by a lot so that you can actually see it moving more than it'll be much bigger than it's actually moving. Below the undeformed shape, it says show, and we want to say wireframe. And click apply. So now we have, as you can see, it's deformed. The wireframe is the original model, and this is what it deformed to. And if you click this button, this will actually animate it. And if you click this director chair button, you can even slow it down here, so you can see what's happening as the load case goes along. See that? And you can do those for each of the 3, and you'll see them moving in different directions, because this was the force going in the X direction. I'll stop that. So, all right. So now we can go. Now this is looking at iteration 0. We can look at iteration 22, which is the final result, and this is after the finished optimization. This is what it looks like. So it's similar in this case. to what the original was in just this this case. But now we want to look at the density results. So these three H3D files are talking about show the this project. I'm trying to see how to.
This is only showing what the loads are going to do to the object. You haven't optimized the shape at all.
Yes, this is showing like the optimization went through 22 iterations of an analysis, and then it edits the model, and then it does another analysis, and it edits the model, does another analysis, and so you don't really reflect those changes on the results of like the forces and the load cases, but there is a results file it gave us of design history that'll show us what it came up with. So I'll just do this. I'm going to make 2 pages. So I have another page here, and in this one I will load. I'm going to load. So I have S1, S2, S3, which are those 3 load cases, and DES. DES H3D. DES is always the design history. So I click Open and Apply, and it should. There we go. So over here I have this load case, and over here I have the design history one. So if I try to go to a contour plot, it doesn't have any forces in this one that it recognizes. It's only element densities. And so I don't really need to do that. But what we're going to do, actually no, we can do this. Yeah, so it says if we select element densities, the contour plot, averaging method, it says to select simple, and we click apply, and so this shows what are the densities of these different elements in here. Now, actually, this model I realized during the tutorial I missed a button. I didn't check a radio button, so this result actually looks different than the one in our tutorial here, because this is what yours should look like. But mine turned out a little bit different because I realized I didn't check a certain box. And so, but it still ran an optimization with according to what I gave it. So, and so down here on the iteration, I can see iteration 0, it all looks the same. But as I move along, iteration by iteration, it'll start actually narrowing down where it wanted to go to. And if I go all the way down to iteration 22, which is the final one, that is the result that it arrived at. And so
blue is what we take away.
Blue is what we're going to take away. So this is the contour plot is of density. So blue is 0 density and red is 1 density, and everything else is in between. So the way we can look at it and actually pull away that blue stuff is the ISO value. So this one here is an ISO value, and so if we do, you can also get that from graphics, I guess. Graphics ISO value is the same thing. It looks like you can get to all these buttons here by just going to graphics. Graphics, contour, ISO value, deformed, all those are there. So we want to make an ISO value of element density, and yeah, and that's it. We just click apply, and there it does it. There's not much, but we can adjust it with this slider bar here. See this? Or we can set it to a certain value. It says in the lab to set it to 0.15. And that's what it looks like. So like mine looks different because I missed that box. However, if we look at if this ever finishes, oh wow. Okay, let's see if we can look at this file then at the design history. It should look a little bit different than this. So as part of your lab, you're supposed to turn in a picture of this at 0.15 ISO value, which is this right here. So I'm actually going to close this. And now that we've finished, I'm going to click Hyperview. And it should open up all of just these results that we just created. Those ones I was looking at were ones I'd created before, a couple days ago. So let's look at these ones that we created now, and then you can do all that stuff. So are there any questions about that? It's pretty straightforward. Hopefully just seeing someone do it once will make it easier to do it yourself. And then I'll just walk around and help you guys do anything else. All right?
We're going to see what this one looks like.
All right.
Were you going to show us what this one just got optimized?
Yeah, I think it's loading. I clicked Hyperview, and I think it's loading it right now. I think. So, and then it'll pop up. But it'll look basically the same thing. It'll just look right this time.